Hello and welcome. We are streaming live on the Amazon Game Tech Twitch channel. We're super excited to be here today, and we've got some amazing content lined up for you. And hopefully this is the first of many. Today's topic du jour is going to be intro to databases in games, and I know Chris and I are both super excited to talk about that. But before we get into any of that content, we should probably get into who these two guys standing in front of you are today. And I guess I'll go first. Yeah. So I'm Nick Walsh. I'm a technical evangelist here at Amazon Web Services. I'm a developer who helps make content for awesome developers just like you so that you can better leverage cloud technology. And with me, I have the amazing guest, Chris, but he'll do himself way more justice than I can. So Chris.
Hey everybody, my name's Chris Blackwell. I'm a senior software engineer here at Amazon, also an evangelist with the Game Tech group. I've actually, prior to Amazon, I've been to Amazon for a long time, but prior to Amazon, I've been in the game industry for well, it's counted in decades, so I don't want to go there. So it's a long time. But super excited to be here talking today. And as Nick said, I hope this is the first of many. So.
Yeah, so Chris is a pro. I'm super happy to be doing this with him today. And again, a great call out that this is a live stream. So contrary to some sort of on-demand content, we are really excited to actually get to field your questions. So we've got chat open on our monitors. We'll be monitoring that. And please don't hesitate to reach out with anything that may be unclear, anything you may be thinking about or wanting to ask. And we'll try to weave those questions in as naturally as we can throughout the stream. So I guess the first question becomes, who should watch today's stream, right? We're doing an intro to databases show.
Yeah, it's a good question. I mean, this is really sort of a 101 level presentation today. And what we're going to do is we've got some slides prepared, but we're also just going to kind of talk about them. There's not like a prepared script, so we're definitely going to be able to jump in and answer questions, but we're going to have some content that we want to cover. This is fairly, so a step above remedial, so we're actually talking about a little bit of the technical details of the databases, but for the most part, this is going to be, if you haven't used a database, or you're thinking about using a database, or you're not sure about using databases, this would be a great talk to listen to. Actually, one of the reasons that I started putting this together was that in my career as a game developer, I actually didn't touch databases for years. In fact, way back in the days, there was a suspicion of databases a little bit, I'd say. In fact, one unnamed company I worked for was a pretty successful MMO. We actually had the entire MMO running on a giant flat file, which you can imagine caused some interesting issues.
Yeah, and I'm sure we'll get into some of the ways databases would resolve the issues that you'd run into with running a flat file.
Yeah, for sure. So I thought it would be great to kick off with just let's talk about what a database is. Probably most of you will know, but we wanted to kind of get the details to make sure you understand what it is we're trying to talk about here and why we think that databases are important to have as part of your game rather than just these flat files or having local file storage.
Great, yeah. So we have right here, again, the fundamental operations for what a database will do. So at its basic level, the value proposition is that it's storing data. But it needs to also do that in a few different ways because, like you mentioned, a flat file can store data. I could write data down on a piece of paper, right? But those are not ideal for many reasons. Yeah. So like one step deeper is we want to be able to optimize the storage and the retrieval. So we want to be able to make sure that the data can be compressed in efficient ways so that we're not using excessive disk space wherever possible. But then alternatively, when we want to be able to retrieve that data, those should be quick and performant calls, right? We don't want to be waiting for data. We want that to happen as quickly as some of our other operations.
Yeah, and with games, that's especially important because you don't want to have any delays in the data, especially if you're trying to get data in that's coming while you have live gameplay. You don't want to have hitches in there. You want to make sure everything's available. You don't have to have people wait for a minute to download all the latest things. So I think that optimization is a real key.
Yeah, like when you walk up to someone in an MMO and you press inspect on them, you don't want to see like loading bars around every one of their inventory items or their equipment. Like you expect it to just be there, right?
Yeah.
And that comes down to, again, that may not be something that's already cached in memory. You have to call a database to be able to access that information, and we want that to happen quickly. And we as players, game tech is so interesting because it's like I feel like most of the people that develop it also are gamers themselves, and so they sort of feel that experience that they want to be able to build themselves into the game. So it's always an interesting perspective.
Yeah, for sure. We're being indicated here we have a poll coming, so our off-camera person here, don't mean to break the fifth wall, but I don't know if you guys have looked at the bottom below the stream here. You'll find that there's a panel that has a survey. We'll be asking some poll questions at various points through. It'd be great if you answer some of those questions. It'll give us a chance to tailor some of our content. We're going to be asking about what your experience is, so please fill it in, and we'll pay attention, and hopefully we can kind of optimize ourselves in terms of what we want to talk about based on those results.
Yeah, exactly. That's going to, again, be in one of the panels below the video feed. So if you scroll down a little, the video feed will go a bit smaller, picture-in-picture, and then you can answer the questions in the poll as well. Not required, but always appreciated. So, okay.
Sorry.
Yeah, no worries. So optimize
concurrency.
Concurrency, right? So once you're handling the ability to write your data or store your data, and then retrieving it, you need to be able to do that for many connections simultaneously. Like you don't have a single player that may be trying to pull this data. You may have many players that are trying to pull that data, and your database can't fall over, and it can't always just put those things into a queue that keeps building up. It needs to be able to handle that in a very in a concurrent way, if at all possible.
Yeah. That's especially important for. I think for the most part, you can typically read a file, have multiple people reading a file, but writing to a file is trickier because when you write, there's there's contentions where you don't want to have data that kind of outdates somebody else's reading and they've read the wrong thing. So part of the concurrency in database handling is the fact that you actually can have some consistency when you're doing reads, and that's actually quite important to the architecture of a database.
Yeah, and this brings up concepts of like eventual consistency and other potential trade-offs you can make, and how immediate you need those changes to be reconciled across all people in the database. But that's like beyond the scope of today's stream.
We'll talk about that a little bit actually when we get into some of the later slides. But yeah, good point.
Great. Next we have corruption. So I think when I hear like storing everything in a single file, corruption and data durability is one of the biggest things that I think about. Like why we just touched on like why writing and like like having multiple people read and write from a single file can be dangerous. But I think at the end of the day, just from a durability perspective, if that single file corrupts, you have that one point of failure, which is never good in any sort of architecture. But that wouldn't that can potentially corrupt your entire data set or database without having a database, right? Databases have lots of really intelligent ways built in to prevent that from happening, having replicas, having ways to handle disaster recovery and so on.
Yeah, and that's that's a big deal, especially disaster recovery. As much as we'd like it to be, hard drives aren't perfect, computers aren't perfect, our code isn't perfect. So we get situations where we might have to back up that data, or have a backup and then bring it back online in an older, less corrupt version. That is especially true when you're doing testing. It's you'll find that you're writing some code and I made a mistake and I wrote some bad data to the database. You need to be able to go back to a point where that data is good. And a flat file just is not a fantastic way to do that. Oftentimes it just means rewriting the whole flat file and trying to catch up from a backup or something. So it's a real pain.
And from a more visceral sort of player perspective, how bad would it feel to do a dungeon, do a raid or something in an MMO, for example, get that piece of loot you've been waiting so long for, it finally dropped from the boss that took your guild so long to down, and then, data corrupted on the database, and now that all gets rolled back, or, completely lost, obviously. The point is that, the data now is a little bit more than just metadata about user accounts. This is maybe hours and years that players may be putting into your game, and you very much do not want to be able to compromise that, because people are extremely invested in that.
Yeah, and there's a flip side to that as well, which is there have been, I've experienced in my career, is database errors that actually allow item duping. And that's another thing that you want to avoid. I shouldn't say database errors; these are actually file errors. And so databases can help you put in a level of robustness, which avoids the corruption, which allow duplication. So
wonderful. And then, moving on to these last two so that we can start getting into the examples of the different databases. We have security. Security at Amazon, we like to say it's priority 0. This is why by default for any of our services, everything is locked down from a permissions perspective until you explicitly add permissions using something like IAM. And from a database perspective, that's extremely important as well. You want the security to be handled ideally at the minimum exactly where your data lives. This could be separate from encryption, obviously, but you want to make sure that not only is that data stored and retrievable, but it is also locked down and access is only given to trusted clients or people who can write to it.
Yeah, in fact, this is a bit of a boring topic, I'll say, but one thing we'll talk about a little bit later too is that along with security, there's a lot of regulations now that are coming with games, and one of the nice things about using Amazon's databases in particular is that we conform to those regulatory compliance. It's boring, sounds like a boring thing, regulatory compliance, but especially in the EU, anywhere where there's data protection acts, you need to be aware of that in games. And so the nice thing is that by using a database that's online, you just get that stuff. And we'll talk about that a little bit more later, but I think that's an important point to make along with security.
Yeah, and security falls into one of those classes or problems that doesn't seem like a big deal until you get bitten by it. Which, once you are bitten, it could be fatal sometimes in certain instances. But that's also a great segue into the last point there, which is scaling, right?
Yeah.
Like you can think like, oh yeah, like I can scale a little bit, or I have a little wiggle room on the current cluster or database that I have. But ultimately, if you are not set up to scale properly to, like assume you release a game or for some reason your game goes viral overnight, if you can't scale to meet that demand, your database may fall over. Your database may not serve those requests. Players may not be able to sign in because you're not able to access those credentials in a performant fashion. So a lot of things that maybe hit you on the nose, like how quickly things are stored and retrieved, but then a lot of concepts as well that you don't think about maybe at first, like security and scalability, but are tantamount to any sort of database in production.
Yeah, and that's certainly scaling is something we think a lot about here at Amazon. But for a game developer, as we all know, this is a real hit-driven industry, right? Mm-hmm. And so you never know when your game is going to be that one that just goes. And the last thing you want is you don't want your data backend to fall over because you haven't prepared for it. So I think scaling is a really, really important to think about nowadays because it's so random sometimes, the fact that, hey, overnight I get 1 million concurrent customers all of a sudden. Whoa, that's awesome. But make sure you can handle it because you don't want that fiasco.
Great.
Looks like we have a new poll question up there too.
Yeah. Next, so we just talked a little bit about these like fundamental data storage retrieval principles and the purposes that databases are going to serve sort of in our ecosystem here. Traditionally, in the years of old, customers may have stored or managed their own databases on premises or done a little bit more of that management themselves. Let's talk a little bit about why cloud databases are really valuable and some of the value propositions that the managed services offerings from AWS, where they really come in and help here.
Yeah. And I see I got ahead of myself with some of these answers already. But yeah, it's actually real key to any game nowadays. I think that regardless, even if you have a single player game that it's just on your phone, players want to have some kind of a back end, whether it be for social, whether it be for storing their player profiles so that you can move from one device to another. There's a lot of good reasons to actually have your data in the cloud because you just want it accessible. It's also it gives you sort of an off-premises way to store it securely. We have another advantage is one of the bullet points here is that we have data that's close to your players. Mm-hmm. And that's actually really important. Is that if you have a database that's sitting in your office somewhere in I don't know, let's say you're in Tennessee or something like that. Well, now you have somebody who wants to come and play your game from Abu Dhabi. You don't want them to have to take that data over the little soda straw that's running under the ocean. And so one of the great things about having an online database is that you have something called an edge server, where the edges basically allow the data to propagate to the user from where they are, which is I think a really cool feature. So I think you get a lot of speed. We talked about the importance of speed in terms of retrieving your data, especially during gameplay.
Yeah, and when choosing a cloud provider to be able to achieve that data closeness to players, like AWS has, I think it's something on the order of like 8, 9 regions. I could be off with this number. A large number of regions, an even larger number of availability zones.
I'm supposed to know that off the top of my head. I don't remember.
But essentially, what this means is that you want your data to be where your players are.
Yeah.
And I think a really great call out here would be, for example, we had anytime we would stream on Twitch, we would have a lot of questions asking about when, for example, a region in the Middle East or in Bahrain would come out because there was a large player base for Fortnite. And due to Epic, one of our standout customers, due to where their game servers were located, we didn't yet, or there weren't other major cloud providers that had availability for cloud infrastructure in that region. And then, just a few months back, actually, we announced the Bahrain region.
Yep.
Epic has now rolled out some of their game servers, some of their databases in that area, and it has immensely improved the quality of life for players.
Yeah, it really has. I think this ping time's come down for sure.
Yeah, exactly. So again, having your data very close to your players is extremely valuable. And we jumped the gun a little bit on scaling when it becomes a hit, but this is really, when you talk about scale, you can talk about scaling a little, but when done right, scaling should work to infinity, kind of, or to any unknown quantity.
Yeah.
And I think that the AWS managed services and the managed databases really help with this. We'll talk about ways in which some of the databases are actually serverless, which makes it even easier to understand how you're scaling them. But ultimately, if you're running something again on premises, you have to add incrementally physical servers and manage scaling up a cluster, and that becomes really difficult. And it falls into a category of things that we like to call undifferentiated heavy lifting. Ultimately, if you're a game studio, you want to spend your time and your effort making a really fun and exciting game for your players and releasing features and making that game as good as it can be. And at the end of the day, spending that, those resources and the engineering hours on making sure your database doesn't fall over doesn't fall into making that game a better experience. So if you can, have a managed service like the various AWS databases that just helps you spend your money get your best bang for your buck for your resources. Yeah,
for sure. That's a good point. That's a point I didn't put on here, but that's really important. Is that we want to make sure that happens. Right?
Yeah, no, exactly. Well, so what you're describing is basically like that's the division of responsibilities, right? It's like with an AWS managed service, we handle the auto scaling or the ability to handle that scaling up of that infrastructure under the hood, making sure you're not running out of instances or servers, and that comes in line with you able to scale up from the software perspective or in the console, or use your SDKs, use auto scaling groups. There are various ways to handle provisioning infrastructure.
Yeah, and I actually had a point there which I totally spaced on.
It's all good. That's the beauty.
My train of thought live.
It's the beauty of doing it live.
So no, what I was going to say was, for myself, as I was saying, I didn't get into databases until kind of later in my career, and always had a little bit of a suspicion, maybe a fear. The DBAs, those are the guys who databases have to do all the sharding and scaling and blah blah blah. So I didn't pay much attention. I think maybe I had maybe a little like MySQL installed here or something like that, or used a pickle database in Python, something like that. But more recently, I've actually been working with the Amazon databases and getting to understand them better. And I'm really surprised at how easy they are to actually use, especially the ones that are completely serverless.
Yeah.
That really is just, there's nothing to think about. You write data and you read data, and that's kind of it.
Yeah, I don't want to jump the gun on talking about serverless with respect to databases, but the biggest first step is having a managed database.
Yes, absolutely.
That removes the need for you as a customer to manage security patching, cycling out hardware, because from reading and writing all the time, the actual physical infrastructure of the hard drives.
None of that's fun.
It's not fun, exactly. and that has to, someone has to walk up to the rack and swap that out and make sure that everything's still available and the electricity's there, and when a natural disaster happens, that things don't, there's a generator that automatically flips on, all of that, and none of that provides value to your game.
Right.
Well, it provides value in that it keeps your game alive and all that. But we spend the time getting really good at that, so that you can spend your time being really good at making a good game.
Yeah. I mean, would you rather spend a week working on getting your database scaled up, or a week adding awesome new content to your game? I think that's kind of the question you want to ask yourself there.
Yeah. So. Regulatory compliance, we talked a little bit, or actually no, we talked about security, but that dovetails into regulatory compliance. So I know that there are, with respect to managing customer data, more well-known examples of this would be like GDPR in Europe.
Yeah.
But this is no longer a customer trust issue. This becomes an actual regulatory issue.
Yeah.
And so with the various AWS managed databases, as long as you are abiding by the best practices that we advise to you and have extensive documentation and writing for, these are typically eligible or compliant with various forms of security compliance.
Yep.
So everything from like SOC 10 to, I know I have a background from like the medical space, so like HIPAA eligibility as well is something that's really big, and anyone who's understands like the confidentiality of patient information, that's obviously a tall task as well. So depending on your use case, there are various levels of regulatory compliance that AWS databases meet.
Yeah.
And at the end of the day, we know that if you're a customer that operates in a region that requires this compliance, we have an extremely vested interest in being able to offer that for you. So.
Yeah, that's a good point. And you know, it's even if you're a U.S.-based developer and you're thinking, oh, do I need to worry about this? You know, these if you want your game to be played in Europe, these laws still apply. So it absolutely is something you got to think about no matter where you are.
Great. So that's a ton of background on databases and why cloud databases in particular. But let's start getting into it, because this is, you know, where's the next step, right? Like, I'm a game developer. I'm looking to start finding somewhere to store my data in the cloud. What is it going to look like? And we have a bunch of different options here, right?
Yeah. Do we want to look at the poll questions at all before we go on and kind of see where we at, or do we have any questions coming from the audience we want to check out?
Yeah, sure. So I was actually about to answer one in chat, but we'll go to the poll
awesome.
questions first. So poll question one.
Multitasking here.
Trying my best. So first question from the poll was, how much do you know about databases? Trying to gauge, you know, everyone out there and the crowd. So we've got a good number of answers here, predominantly for not much. That's why I'm here. So that's really great. You know, we're happy you're here. And again, don't shy away from asking any questions in chat. I know I've been working on a typed response to one, and we'll be weaving in the other ones verbally as we keep going on. Then for question two, we asked a question about what type of data you think you'll store in a database versus on local disk. And I named some examples we've seen in here, like user inventory maybe. But as we go through these different database offerings, we're going to have examples of each of them.
Yeah.
So use this as sort of a thought exercise. Even if you aren't sure of your answers, try and see here and see how, after we go over the different database and the applications of them, how much you've learned or where you think you would apply each of those.
Yeah, for sure. And we are probably getting ahead of ourselves with some of these questions, but definitely as you listen, go ahead and fill in the poll, and we'll take a look at that. It'll help us kind of understand what we can talk about, and if we need to follow up, what a good place to follow up would be.
Yeah, and last poll question that we have on here for right now is if you're asking if you're currently working on a game. So you know, we're curious as to what type of content can better serve you. So if we understand this is better for scaling out production workloads, or getting spinning up a hobby project more quickly, or you know, just trying to gauge your level of background and expertise, that helps us both within this presentation, but also going forward, so that we can get better content for you.
Yeah, that's actually an interesting point. You know, when I'm at home, I'm crazy. I code at home, even though I code at work too. Almost every time I start up a project now, regardless of who it's for, if it's just for myself, I'm going to go and set up some kind of a little database to store stuff in.
Yeah.
So it's a good point about the hobby projects, because it really is a good way to kind of launch yourself and not have to worry about that component.
Yeah, and I think you know, last point, I guess, before we get back into the databases, is that it was really cool that you mentioned before that, you know, you had spent a ton of time in game dev working on tons of really exciting things, and you may have just never touched a database.
Yep.
And like, I think that speaks to the complexity of modern applications, modern games. You know, you may be really an expert in a subject matter expert in a certain class of parts of the stack, but that doesn't mean you know much, if at all, of a different part, and that's totally okay.
Yeah, very true.
And there, you know, especially when trying to tailor content, you know, you can have everything. There's a matter of like understanding like how advanced of a developer is somebody, but then also you know, what of the theory do they know? So we're excited to be kicking this off with a 101 level, and then going forward we'll see what resonates for what parts we want to dive deeper on.
Yeah, we're going to go deeper into this for sure. It's actually it's an interesting point that you make, because I think that it really is, games, you know, have tended to be very specialized. Like, you're a gameplay programmer or a graphics programmer, especially with the new sort of indie games. Suddenly, you're the everything developer, right?
Yeah.
And so
full stack or full game, I guess.
Full game. And so being able to have you know, something that makes it a little easier for you to deal with is pretty nice. It's nice to have these tools where I don't have to go in and learn all of these bizarre technologies and spend 2 years actually figuring out how to use them. So that's a really good point.
Yeah, and one last question, I guess, this one's from the chat.
Yeah.
This is from Blue Tiger Animations, asking, since Fortnite is a big customer, do you guys support UE4, that being Unreal Engine 4, right?
Okay, I'm going to let you answer that one.
Yeah, sure. So I think this comes down to first explaining a little bit about, you know, and again, I won't try to dive too deep on this, because I want to make sure we have enough time, we're not dragging things out. But UE4 is going to be the game engine that's, so you have two parts, right? You have the game server, and then you're going to have the client. The client being what a given player has running and rendering the environment and all of that on their system. And so for UE4, with respect to, I'd assume, GameLift here, we have the ability for the game developer to scale out their game servers, which again is going to be the compute that powers your online game, essentially infinitely or in an auto-scaling fashion. And so the game developer packages up their executable for the like in this example, UE4's server-side code. You put that into GameLift as the package, and you kind of just hit launch. You select the regions and the necessary configuration, and that handles the auto-scaling of your game.
Right.
So it's a little bit less of like, does AWS support UE4, and more of, like, what parts of UE4 are you trying to interact with? Because you can also have, other callouts from the client side to, let's say, for example, to a like an API gateway for authentication if you're trying to have the user log in. So that may not be a GameLift server. That may just be an authentication or an authorization service. You could make callouts to other of the ML APIs to try and serve personalized requests when your user signs into your game launcher. There's various ways that Unreal Engine and any other or other game engines can work, and the extent to which they work is kind of specific. But I think that broad generalization that sort of works for anywhere you can write and customize some of your own code, both on the client and the server.
Yeah, that's actually a really good point. Sorry, I said it a lot. It is a good point, though. So one of the nice things about using online services is they're sort of engine agnostic. Because we do indeed have SDKs that you can install into like Unity. You can install the C++ SDK into UE4. That's typically something you're going to do on your server-side code. We'll actually talk about that a little bit towards the end, how you architect that. But generally, you don't want your clients calling directly into your database. That's just usually not a great idea.
For security reasons.
For security reasons, yeah. And so the nice thing is that every game engine that's out there allows you to make HTTP REST calls, right? And that is sort of the entry into the Amazon services. So no matter what you are, if you're UE4, if you're Unity, if you're Lumberyard, if you're CryEngine, all of those are effectively compatible with our database services because you just access them through this common standard of HTTPS, and you're there. So the answer is yes. I mean, if you ask me what game engine we support, it's like as long as you support HTTP calls or HTTPS calls, you're golden. So
wonderful. Okay, I'm ready. I'm pumped.
All
Let's
right.
talk a little bit about the
specific stuff
various
here.
AWS databases.
Sure.
So we've got a bunch here. We're not gonna let's not dive too deep on them
Yeah.
because we have a slide dedicated to
Yeah.
each of these. But essentially, we have 7 that we're going to talk about today. There are even more that exist in the AWS ecosystem, but we've picked the ones that are probably the most prominent, most applicable to game developers. And of these 7, I think that we are probably going to lean into the like about 3 or 4 of them or actually about 5 of these, and then TimeStream and QLDB are more for very niche use cases.
Very
I'd
specific
say.
uses, yeah.
Yeah.
So one thing we're going to talk about first, since this is sort of an intro, is you've probably heard the term SQL and NoSQL. So let's talk a
Is
little bit
SQL
about
the same as SQL?
SQL. Oh, sorry. Yes, SQL is the same as SQL.
Oh
Sorry,
no, I'm
that's
not
a
saying
very
that
good
it's
point.
correct. I'm just saying you may have heard it in that
No,
way
I know.
as well.
You say that,
I'm just
and I
teasing,
forget.
yeah.
No, I say that. I'm like,
I say SQL as
people may
well.
not have heard that. So yes, SQL or NoSQL or SQL or NoSQL. And I've actually put on the slide here. Basically, we have Aurora, which is our SQL offering, and then the rest of the databases we're going to talk about today are considered to be NoSQL databases. And let's talk a little bit about what that means.
Yeah, totally.
So SQL databases are sort of more historic in terms of their development. They solve some really specific needs, I think, and they're very, very similar to like a spreadsheet, right?
Yeah.
You have data in rows and columns, so usually you have sort of an index on your column that tells you what that data in the column is going to be, and then you have another index on your row, which is saying here's the specific entry into the database. So what that means, though, is that you kind of have to have a good idea what your data is going to look like before you put it together, and that's called a schema. That's something you may or may not have heard, but it does mean that you kind of have to predefine structure. So it's a little bit limiting. It doesn't mean that you can't ever change that, right?
Yeah.
Over time, you could add stuff to it, but there's another requirement, which is that basically if you add columns, you always have to have data for that column.
Yeah.
Which means that it's very possible if you add a column, you've got to go through millions of entries and add something,
So a really like tangible example of this would be if you have let's say you're trying to store character stats in a SQL database, and you may, maybe the stats are the same for every character, and SQL may be a good look for that. But from a performance perspective, if you were to add a new stat, you add essentially a new index, like you said, a column for, let's say, dexterity. It's a new stat in your game. You would have to then go in for every single user and apply value. Now, maybe that makes sense in an example where you have what's known as a dense data set, where you have meaningful values in every one of those spreadsheets. So imagine an X by Y spreadsheet where all of the values and cells are filled in and have meaningful data. What you want to start avoiding in a SQL or a tabular sort of scenario is when you have sparse data. You have a bunch of columns or indexes where you're just putting placeholder values like a 0 or an NA or something like that in the column because it doesn't even apply to that given entry. That's where you start to understand, well, the schema I've decided for this data set doesn't really fit this very well. I'm losing performance because there are just a lot of cells that I will never even read because I know that they aren't valuable. And so, logically, when we think about how we want to lay data out, a lot of people, their first reaction is to throw it in a spreadsheet, and that's natural. But we start to find scenarios in which that starts to break down. And the naive solution of just making smaller and smaller and smaller and smaller SQL tables or relational tables doesn't always make sense.
Yeah, that's a good point, and especially for games. The good example, I actually show this later, is we think about an item, right? An in-game item. You might be armor, you might be a weapon, you might be a magic item or whatever. All of those have different stats, right? And they all have different purposes. So you could potentially wind up with this table which just has a bunch of blanks, which is, because my magic item doesn't have a damage value, for example, or an armor protection value. So it's actually very true in games. And there's so NoSQL was actually brought about partly to solve some of that problem. There are a couple things I just want to, before we skip off of the SQL databases. I shouldn't make SQL sound terrible either, right? Because it actually has some very good features. One of which is that querying SQL data is very flexible, and there's a whole language, which actually is where the SQL name came from, which is the structured query language, which allows you to basically get any data at any time without having to worry a whole lot about how the database is specifically indexed. There's some stuff you can do to optimize it, but in general, it makes it very easy for you to go and say, like, find the 10 closest items to this item in terms of damage. So it's great to have that flexibility. The other thing is, and we talked a little about this, is consistency. SQL databases tend to be transactional, and they comply to something called ACID, which I can't even remember what the acronym is for. You probably remember.
The first one's atomic.
Atomic,
consistent. It's not.
Is it idempotent? Maybe.
Idempotent, and then D is, I don't
something.
Remember.
Okay. So
but the idea is each one of these transactions should essentially result in, for every input, you're going to get the same output every time. You should not, there are scenarios in things where your data will be eventually consistent, where you have multiple people reading and writing in like a NoSQL scenario where that may not be the case. And that ACID compliance is something that is like unilaterally considered valuable, right? Like there's a lot of work in the NoSQL community to be able to try and get to ACID compliance. So as a part of some of those trade-offs, having ACID compliance on the SQL side is very powerful.
Yeah. So we go to NoSQL, is that we talked about this earlier, is sparse data is okay. You can actually have data just being kind of assigned as it comes along. So you have an item, you want to add a new attribute to it, you can just put it in the data. This is a magic item, so it only has the attributes that go for the magic item. You have a sword, it's only attributes that would go for a sword. So it kind of solves that sparse data problem. Now I should caveat, this is some of the more specialized NoSQL databases we'll talk about have some more restrictions on the data, but this is the general sort of NoSQL idea, is that you have this big glob of data that's keyed somehow, and you can just start adding stuff to that with no problem.
Yeah, and I think the easiest way I think about the difference between the two is become a very visual person. So with SQL, if you can think of it almost like an array, each entry in your database is an array where you know that at index 0 you have property A, like maybe your health. At value 1 you may have your mana, for example, and so on and so forth. And that will be consistent for every single entry in your SQL database. Right. On the NoSQL side, you may have, like you said, you may have values that are present for some characters and not others. But you also get into a world where you can have nested sort of parameters. So, you know, in SQL, you have one layer. Everything is in the root of that array at one index level. So in a NoSQL database, you could have a character be an object in your database, or like an ID for the character for an account. And then you could have one object that will be like stats, and within that stats nested object, you could have health, mana, dex, strength. But then you can also within that character's nested object have something like equipment, and then you can have a list or a you know, key values of different equipment or other things, right? Point is that you're more flexible on structure. It helps you when you have some sort of sparse or like inconsistently sized or keyed data.
Yeah, and that's actually, it's interesting when you look at the history of SQL databases. There was a lot of effort put into trying to make SQL databases look like objects from an API standpoint. And I think those were all consistently terrible. I don't know about your experience, but
databases have come a long way, man. There's a lot of different ways. And again, I think that like you know, built on the shoulder of giants, right? Like all of the forms in which these databases take today are built on a lot of the learnings from what doesn't work over time.
Yeah, and I never want to take any of this as knocking a SQL database, because it has some very important uses, which we can just get into.
Yeah.
So let's go ahead and switch to that slide. So first what we're going to talk about is our SQL offering. Now the SQL database for Amazon is Aurora. Which is also, you might hear the term RDS, and Aurora is, how does that work? Is it, Aurora is part of RDS?
Yeah, so when we think relational databases, we have, again, to the managed service offerings from AWS, which again, we handle the the underlying infrastructure, security patching, and you can just worry about making your queries and putting your data in. We have RDS, it stands for Relational Database Service, and that is what any database offering that falls within RDS constitutes all of those managed service offerings. But the additional part of RDS is actually the fact that it does things like automatic failover in certain scenarios, like faster disaster recovery, and we've also optimized a lot of the engines that run under the hood on RDS, so you can use a lot of the similar bindings that you use for the interfaces. So for example, if you're using like MySQL with Aurora, or you're using Postgres for Aurora as the backing engines, they'll actually run 2 to 3x orders of magnitude faster than the open source equivalents. So this is where, you know, it's not just a matter of you paying to get your service managed, you're also getting more performance and more bang for your buck there as well. And so it's 2 to 3 times faster, but then we also bill you, when you look at the whole TCO, at 1/10 the cost. So it is confusing. You have RDS sort of at the top as the broadest spectrum of all of our managed database offerings, and RDS includes specific relational database benefits on top of the fact that it's a managed service. Then within that you have Aurora, which is a relational database service, and then within Aurora you have various engines you can select, of which examples are MySQL, Postgres, Oracle DB, MariaDB, and SQL Server. I think I got all of them. Yeah. So you have a lot of options, and again, we mentioned, you know, there's whatever your particular workload may already be on, if it's on premises or you're deciding on a new one. The way we talk about Aurora and what makes it so amazing is it's the first database built for the cloud. And what I mean by this is, I'm going to go on a little auto-scaling rant here, but when we're thinking about scaling up infrastructure, you want to be able to most closely tie the part of your infrastructure that you're scaling up to the compute or the demand of that particular workload. So, for example, on a database, it's actually not just something that reads and writes from data, right? Like you have a compute layer that resolves that looks at the requests that you pass to it, and then it's also going to have to figure out what machine code it's running to actually pull and service that data. You then have the storage layer. That is going to handle the actual putting of data into either files or like into memory or so on and so forth. And you want to be able to scale those differently, right? Like let's say I put a ton of data into my database, so I need to scale out storage, but it happens in a very slow or controlled manner. Well, my compute layer shouldn't scale, but my storage units should scale extensively. Now, traditionally, these kind of come bundled into like some sort of black box or a unit or a server, and you scale that incrementally. But what that means is that traditionally, developers are paying for compute or storage that is not being fully utilized. And so with Aurora, this was the first database offering that we had that basically allows you to be able to scale those independently of one another, which passes on cost savings to the customer. So there's a whole bunch of papers on it, enables you to use there's a lot of information on it out there, but essentially it enables you to more efficiently pair your scaling of infrastructure to the workload demands.
That's cool. And in fact, Aurora has a relatively new feature, which is a serverless mode now with the serverless API, which is kind of cool. So it's the first time I've ever used a SQL database that actually has a serverless API, which means that you don't have to do any of the here's the type of instance I want. You just write to an API and it writes the data. So that was pretty exciting.
Yeah, and so when you think about I just mentioned a lot about you have compute, you have storage, and where does serverless come in here? Essentially, the idea is that if AWS has done the legwork to sort out how storage is being handled under the hood, then essentially all the developer needs to worry about is, well, how much data do I have in my database at one time? And so the data may be in there, and then we will scale up under the hood if you have auto scaling enabled for services like this. The underlying hardware or virtualized hardware that is powering that. And on the serverless side for databases, this is something that, again, if you're used to dealing with managing your own database or you're a DBA, connection pooling. So the way in which you handle concurrency, which is something we talked about before, is very important. There are scenarios in which, even if every individual person's request is very small and very simple to resolve, the very act of flooding a database with connections, connection requests rather, or maybe from the client, can actually cause it to lock up or not serve certain requests or drop certain requests. And sometimes the workaround there is very complicated. And there's a lot of work that's been done to figure out how to keep some of those connections alive and tuning that. With serverless offerings for Aurora, you get a persistent HTTPS endpoint that actually fronts your entire database. So AWS will handle all of the connection pooling and all of the intelligence around that. So you just have to worry about querying a particular endpoint or hitting an endpoint with whatever operation you're trying to do for your database, and you don't have to worry about optimizing how that query, that traffic to the database.
Yeah, that sounds good. I have to admit, as this is one of those reasons I've been kind of avoiding databases. You start to talk about it, it's it's got all these connection issues and DBA, and I'm like, oh man. So, to put it in a nutshell, serverless just avoids all that.
Yeah, I think the way we like to describe it is it just works.
Yep.
And that's the idea, right? You don't want to have to think about it.
Yeah.
And there are ways in which you can handle, we have concepts called auto scaling groups. You have, especially in the database, that's more on the compute side for instances, but for databases as well. Once you start getting into the serverless fashion, you're not dealing in, I have 5 instances of type T2x large, right?
Yeah.
You're now dealing in what are abstracted compute units and abstracted storage units, and there's a clear delineation between how much those cost. But the point is that you don't have to worry about, does for 10 compute units, is that going to run at maximum throughput on a T2x large instance type?
Right.
And that's a question that dedicates entire teams to making sure that you're not provisioning infrastructure, or you're optimally deploying applications and workloads for databases on adequate servers. That essentially is just another part of the pipeline that becomes abstracted away.
Yeah.
And the RDS data API, I'm pretty sure, doesn't cost you anything additionally on top of that. Don't hold me on that. I will look into that.
That's a good question.
But it's actually enabled. It's really easy to use.
Yeah.
I guess this will be one of the last points before we move on here. Actually, no. We've got some examples to talk about.
Yeah, we should get to those.
But it's enabled with one click in the console, actually.
That's
so once
great.
you have a supported Postgres or Aurora MySQL relational database up in your AWS console, you can actually go in and with one button press,
literally a checkbox.
it's a checkbox.
Yeah, I've seen that.
So super easy to get started with if maybe you've worked with these types of databases in the past and you're looking to see what's new with the hottest features. That's definitely something to check out.
Yeah. Looks like we had a couple more polls come up, so if you guys want to check those out while we're chatting here. So I think you bring up, let's talk about these use case examples we have here. So I should say that all of these examples that we give are, yes, you could actually implement any of these examples probably in any database. Mm-hmm. I think the key point we want to make is that different types of database have different specialties, right? And so you want to really pick a solution, a database solution that matches what you're trying to do, because what you can wind up doing is creating something where, well, yeah, it works, but it's not, it's not going to scale very well, or it's going to be very expensive, or it's going to store stuff suboptimally, or your searches are going to be super slow, or something like that. So the reason we give these examples is that they're good fits for the type of database we're talking about. So. For the SQL database, some of the examples you give here, inventory is a really good example for SQL database. There's a couple different ways you could do it. SQL databases tend to be pretty good, though, because they give you that transactional ability to make sure that when an item is actually put in the inventory, it is in the inventory, it's not duplicated, it's not lost. You have an assurance with the transaction that this actually happened. And if you're not familiar with the word transaction, so it's very much like, you can think about, like, I go to an ATM and I put my PIN code in and I get money out. You want the bank to be sure that that money has actually been, correctly taken out of my account. You want to make sure that the right amount of money comes out. You want that all, and you don't, the bank doesn't want you to like, oh, that didn't get recorded, so suddenly you have $100 that you maybe didn't have before.
Essentially, you want that transaction to be as tight, like airtight as possible, right?
Right.
The second, like, you don't want any space between the time in which you are given money and the bank loses money in a withdrawal scenario, because any sort of space between those two operations is an attack vector for people to either exploit through duplication or just bugs, right? So you want to be able to, like, those transactions or those handoffs between operations to be as tight as possible, and that ACID compliance is what enables relational and SQL databases to do that.
That D is probably really important in ACID.
Yeah, it's always the last one that gets you.
So similar to inventory, we talk item shops and trading. Another good example where you want to make sure that you have this ability to kind of track those transactions, because especially with trading, if you want to have people trade items to each other, you don't want that to go wrong. You don't want somebody to suddenly not have the item, or that was supposed to have the item, or they pay for it and didn't get it, or they pay for it and it winds up in somebody else's inventory. That would be really bad, right? So that's another really good example of where you can use SQL database.
Another thing about immediate consistency versus eventual consistency is that there are certain scenarios where it's not just about the transaction being guaranteed to be correct.
Right.
It's about it needing to be correct immediately.
Now.
So like when you make a trade but the item doesn't appear in your inventory, I don't think any sort of gamer would be like acceptable with, like, the item will show up in 8 hours.
Yeah,
or
10
up to
minutes
8
later
hours.
you'll have this item. Yeah, no, that's not going to work. You're right, and that's you'll see that the eventual consistency is a feature of some of the NoSQL databases we'll talk about later, if you haven't heard that term before. But it's basically saying that at some point in time, all this will agree. SQL databases are always consistent. You can guarantee that if something is put in your SQL database, it's going to be there right away. So that is one big difference. Another thing I call out here was high scores. Now, high scores, there's actually a couple different places you're going to store high scores. What a SQL database is great for is storing high scores when you want to do any kind of, like, historical or analysis on the high scores. We'll talk about in-memory in a few minutes. In-memory is actually a better place for your sort of immediate high scores that are shown to the player. But if the player wants to do things like, show me the 10 closest players to me that live within a 50-mile radius, that's the kind of thing where you want to see that in a SQL database. Or you want to go and say, like, well, show me my trend of high scores over the last 5 years,
Because you may have a consistent index for each day, and the high score, the index may be the both date as well as the score for that day.
Right. It all goes back to that flexible querying, right? Is that the nice thing is with a SQL database, relational databases, you can kind of have any kind of query across the data that you want without having to worry about a lot of overhead. So
wonderful. So let's take a look at actually, like, what that would.
Yeah, sure. So the next slide here is actually going to show a little bit what the data looks like, what the query and the data looks like. So I've made this awesome. Here's my game, and you can see that the query itself, if you're familiar with SQL, the red text there shows the actual string that I use to make the query for this data. In this case, I'm just saying give me the whole table. My table doesn't have a whole lot in it. This particular table, I was just showing that in the table, you've got to have, every item has to have the same set of data. So you can kind of see what I've done there is I've got, there's this first item, it's got there's 2 fields, next item has 2 fields. It's very much this array, like you said, an array structure. And this response is actually one I actually pulled this from one of the database examples I have. It's a small database. So this is actually the kind of output you'll get, very structured, but all consistent.
Great. Yeah, and like we said before, the static schema. So before you even put data into your database, you have to predefine what those indexes are, or those indices.
Yes.
And so here, the example indices would be like the name, and then let's say stats, and you have under stats or parameters. You have like the price, the cost to buy the weapon, as well as the attack, which will be in a game where you have a consistent set of statistics that is highly like homogeneous across all items, then a relational example may make sense.
Yeah.
But in a different type of example for an inventory where, let's say, all of the items have, you have a significantly larger number of characteristics on the items than you do the number of items themselves, that's where you may want the flexibility on
Yeah,
SQL.
well, I kind of showed that here with this example. If you look at the very last one there, which is the scepter, so our scepter is actually like a magic item, so it doesn't actually have any attack damage. So it has this null value in there, and that's actually what we're talking about, the sparse data.
Yep.
This is an example where you've got these sort of wasted entries in the database where there's just no data, and so in some cases it's okay to have those, but you don't want to have a SQL database that's full of those, where you have 100 pieces of data with 4 columns, but then 90% of that is null. That's just not a good way to go.
Yeah, and then we've actually got a question on chat from Mad Macedonian 9. They wanted to know a little bit more about what we were talking about before with HTTPS queries directly to Aurora.
Oh, sure.
What was the name of that? And so that is actually the Amazon RDS Aurora Data API. And what that enables you to do is essentially, again, have a HTTPS endpoint that will be persistent. So regardless of how your database is scaling under the hood, you don't have to worry about changing your entry point of where you're connecting to it. You don't have to manage connection pooling. And you can just always send your transactions directly to that API
That's right.
endpoint.
Yeah, and we'll talk a little bit later. If you are interested in actually getting that data directly to the client, without having a server in between, I'll talk a little bit about how we can set up basically a client service, because you don't typically want to actually call the API, this data API, directly from the client, because you have to be so careful with the security on that, making sure that you don't allow certain bad queries. In fact, there was in the poll I had a little joke there. If any of your ex-KCD fans. Talking about sanitizing your database inputs, it's very hard to do that, and so you want to have that very, very controlled. You want to actually have those queries made somewhere aside from your client, because as we know, clients are always hackable, right? Like, as long as I have code, I can do whatever I want with it. So what we want to do is we want to actually have the client do something like store this in the database, but we want to send it to another thing that says, well, here's how I actually store it in the database.
Yeah.
And so we'll see an example of an architecture later where you have a little bit of stuff before you call this RDS API with HTTPS. So we would be using something like you said, the API gateway, or perhaps like a application load balancer that would give you an HTTP endpoint that you would call just like a normal HTTP request from your code, and it'll go through and do some mechanics, and then actually wind up calling and storing that data or retrieving the data.
Yeah, and the big two things that we're thinking about doing on the load balancer or the gateway there are going to be sanitation of the data, so you make sure that you don't have any sort of malicious queries or people don't try to do like SQL drop tables.
Yep.
And then authorization, right? You want only people who are, if you're accessing game state data, the only people that should be able to access that are authorized clients that have already have the proper tokens and authorization. So those are two of the really common things you want to preface your database queries.
Yeah, and also I would say this is all unfortunately about malicious users. It's flooding is another big problem. Is you got to be really careful about. You don't want somebody calling your database API 10,000 times a second, because that can cause, the game's going to slow down and cause unexpected charges. So by having something in front of that, you can prevent that from happening.
Using something like throttling.
Throttling,
exponential backoff is a really common one. So if someone's disconnecting, or like some part of the application is not working, if someone is hammering your database with a call every second to try and get a piece of data, a really common technique there would be to say all right, well, after the first 10 attempts, if it's still declining, make that like a 10-second wait before the next one,
Right.
and then after 10, make it 100 seconds. And exponential backoff works really well to prevent your database from getting flooded.
How are we doing on our time here, by the way? I want to make sure that
We're running a little
long.
I
Okay,
think.
let's
But
burn through some of these slides then, and just make sure we can get the basic information.
Yeah, sure.
So here we got some examples for key value store. So key value store is your sort of first basic NoSQL database, where it really is just a map, like you're talking about. It has a key that has a glob of data attached to it. Some of the examples we give there is, you'll see I say a lot of states, player states, game object states, game states, quest states. It's really great for any kind of data that might have changes in form per every value that you put in. So those are really good examples of the kind of things you want to store in something like Dynamo, which is a very, again, serverless, easy to access, no management required, NoSQL database.
Yeah, and like I don't want to undermine how powerful Dynamo is, because when you get off of the relational world and start dipping your toes into NoSQL, you can open up the console and simply start putting data directly into DynamoDB. It's completely serverless.
Right.
So you don't ever think as a developer about any of the underlying infrastructure.
Yep.
You have your data in wherever it lives or wherever it's from, and you can put it into DynamoDB tables. And you don't have to worry about iteratively making your table larger over time. You're only ever getting charged for how much data you have put into DynamoDB, which is extremely valuable. You don't have to worry about shutting it off, turning it back on. As long as you know you're using that data in that database, and let's say you don't have a bunch of data that's sitting there doing nothing, you may want to move that into more cold storage in certain scenarios.
So it's worth talking about the eventual consistency quickly.
Sure.
So I believe, and you can correct me if I'm wrong, is that typically Dynamo is consistent pretty quickly as long as you're writing to one region. Am I correct in that?
Yeah.
It's when you have multiple regions that are set up with data that's replicated across the regions, that's when you start to run into eventual consistency issues.
Yeah. So. This comes down to like how the compute layer operates with all of the underlying storage, and if you have replicas both within a region or cross-region replication, and then resolving that such that your entire global state is consistent.
Right.
There are reasons why that will be consistent in SQL and or immediately consistent due to that ACID nature and the atomic nature of the transactions. Whereas in Dynamo, it may not be. It will be what's called eventually consistent.
Right.
Which means that you can guarantee that eventually everything will work as is, or your global state will be consistent. Where if two people, like if I put a piece of data in North America, if I update something and I immediately then read from North America for that entry, and someone across the world in Asia from a global replica reads, that we may get slightly different values.
Right.
But then a few seconds later, once it's then consistent across all of the tables, then the values will be the same.
Yeah.
And so it is eventual consistency is an understanding that when data is written in one region, it has to essentially propagate across the various nodes or regions across your database, and to design around that and with that understanding in mind. And this is less of a reason not to use a certain tool, and more of understanding what workload works well for different tools.
Yeah.
Like when is immediate consistency needed? When is eventual
Exactly.
consistency possible? Because when eventual consistency is possible, that is often a lot more convenient to be able to use. Like if you're very write heavy and you don't expect to be able to be reading queries often that are going to be happening milliseconds after the write, then that eventual consistency, that it may be eventually consistent, but the timeline in which it takes to be eventually consistent may always be available for your users. Another thing that I would be remiss not to call out with Dynamo is its ability to handle scale and large throughput.
Yeah,
so
for sure.
we actually use DynamoDB at Amazon for our retail side, and we handle all the transactions through that. And so we had Prime Day a little while back, and all of those transactions are powered then through DynamoDB, and I think it handled on the order of millions of transactions per second. It's like, I think number is like something around 13 million transactions per second peak throughput.
That's okay.
Yeah, it's okay, right? Which again is immense, and I would joke about, like you want to make sure your game can scale if it goes viral overnight. But if it handles Amazon Prime transactions at peak throughput, I think your game will likely be okay.
Yeah.
But we have a much deeper dive on that we can get into in other episodes.
Yeah,
but
for sure.
So it's the ability for that to scale throughput. It's the ability to scale to any size or like very large collections very effortlessly. And then the last one I really want to say is the performance of those queries. So you can have I think it's like sub 10 millisecond or like millisecond level queries on your data, which is another order of magnitude faster than a lot of other offerings, and that is due to optimizations on the engine, but as well as the ability to have your database very close to your user.
Yeah, and this comes in one of those trade-offs where you're going to make a choice kind of between SQL and NoSQL. The sort of gotcha with those fast queries is that you have specific keys to your data that you've assigned, that you've said these are going to be optimal keys.
Yeah.
And those are the keys you want to use to get those really fast things. So you're sort of trading off between I get this super flexibility in terms of where my data is structured, but I get less flexibility in terms of the queries because optimal queries are going to require that I tell what we want to query first or what questions we want to answer.
Yeah, and I know we're spending a lot of time on SQL versus NoSQL, but I think we've also provided a lot of background that'll be consistent for some of the other NoSQL offerings going forward.
So I'm going to pop over. This is
on schema design. If I had to give a top level overview, it's like in a SQL world, you have to put a lot of thought in the beginning before you start it. Otherwise, it may be very painful along the way. Whereas with NoSQL, it's often very flexible to start.
Right.
And then over time, it's very rare that maybe your entire structure or there is a schema, even if you're not explicitly defining one. It's more in terms of like what are your like sort keys.
Right.
What are in the structure of your objects? What are the ones that are at the rootmost part of those objects, and how are you sorting in memory around the database? And those are things you can optimize over time. And the honest truth, especially around a flexible database structure, is that your data may change over time, such that those needs may change.
Right.
So it's constantly it's an ongoing tuning sort of effort. But the point is that you can get started and it's as flexible as you need it to be. And sometimes, if performance is all good, you may never have to go and actually fine tune those sort keys. But there's a lot of content out there. If you're really interested in being able to figure out or learn more about NoSQL, primary indexing, secondary index tuning, Rick Houlihan is a NoSQL specialist here at AWS. He has an amazing reInvent talk. I think it's like the most highest scored or like most viewed reInvent talk of all time. He does a really great job. I'll throw a link to that in chat in case folks are interested. But that is definitely 300-400 level stuff, so won't dwell too much on that.
Yeah, okay. So I showed a quick example of a query here. The one thing I wanted to point out was you can see that the data coming back, I have more data coming back from one example than the other. This is showing how the data is more flexible and doesn't have to have a rigid structure. So a quick talk about the in-memory. In-memory is when you need super fast access, and so good examples of using an in-memory database would be any kind of matchmaking where you need to have like super fast connections between people. Current leaderboards where the data is coming in really quickly and you want to be able to distribute it really quickly. Any kind of like server session management where you've got like server tokens that need to be, are going to be constantly being flooded in and out. And also, in-memory is very useful as a cache to make things super fast in front of other databases. That's a real typical use for it. Amazon's entry here is Elasticache, which actually comes in two flavors. There's a Redis and a Memcache flavor, which are just two different, slightly different technologies, slightly different APIs, but it's compatible with both, and you can kind of choose how those go.
Similar to how with Aurora you have various underlying engines.
Right.
If you are, again, hosting your own in-memory database, you may be familiar with Redis, you may be familiar with Memcached, like you said. And Elasticache offers all of the managed benefits, or the benefits of managed service, with those as the underlying engines.
Right.
So again, you're not necessarily learning an entirely new service here. The idea is that you can often take the code that you already have running if you're using Redis or Memcached, and then oftentimes drag and drop. I can't promise that exactly every single one is completely compatible, but to my understanding, that is the goal, right? And if there is ever any sort of gap, we are always looking for feature requests from customers to prioritize what those new features will be to ensure compatibility as closely as we can, or B, if there's just new features that may not even exist in something like Redis or Memcached that an Elasticache customer is interested in, we're always excited to hear that.
Cool. Next one to talk about is Graph. This is a newer database that we're seeing. This is for basically managing relationships between objects. So good examples are social graphs, gameplay recommendations, cheat detection, like looking for patterns of fraud. Those are all good things. Neptune, Amazon Neptune is the offering that we have here. This is actually one of the things I'm really excited about because it offers kind of a new way to look at data at scale. And I think there's some real exciting gameplay opportunities for working with graph databases. Thinking about things like we've seen games that are they're adaptive in terms of the relationships in the game. Where I go and attack the ogre king, and now all the ogres hate me. Imagine you have a giant open world, and you have thousands of different tribes in there. Being able to manage that relationship and actually have this real dynamic living game. And this is really some exciting stuff that could be done with this.
Yeah, and I think this is something that we'll talk about when we close out. But it's important to call out here is that there is no one database to rule them all. And that makes sense at the the one size fits all solution for everybody. But I want to harp on the fact that that may be true not just for a company. No company may be a single database company, but even a given workload or data set may have two different types of databases that are ideal for two different scenarios. And this is not uncommon, right? So let's say, for example, you are trying to have your production game server that may run SQL, right, or that may run NoSQL. But when we're talking about something like trying to detect fraud in player behaviors, that becomes much more of an introspection question. It's not just about, well, can I get my data? It's like, well, how easily can I ascertain maybe a complicated set of my data? And so questions like, here we have things like genres, movies, places, artists, people. If I wanted to find out, all of the people in my data set that have seen the movie that was produced by artist X, of genre Y. That may be a really complicated query, like not just the people, but the friends of those people, right? So you're no longer querying on a primary index like you would in a database, or even in a key, right? Where it's like, well, look for all of my users and look for this situation. You're actually looking for pairwise interactions between items in your data set. And that fundamentally is possible in some of these other traditional NoSQL languages, but it's really difficult because now you're doing things like joins and, it may not even be performant, which is another thing, right? Even if you get that spaghetti code query sort of working, it is by no means necessarily optimized. And I feel like most of the time when you're dealing with graph data sets, you also are dealing with a lot of data also. I feel like you're rarely dealing with small numbers, so that optimization becomes really valuable. And so I don't have a query listed here, but essentially you can use some of the open standards for graph model queries, such as they have interesting names like SparQL, Sparkle it's pronounced, or Gremlin, Apache, Tinkerpop. Very interesting. But basically your queries resemble something like you start with your graph in the beginning, so you do like G, and then each parameter after the G is essentially a filter or a narrow down. So if I want to find all that complex interaction I described before, it would be like G dot person dot artist dot producer, or artist parentheses producer equals something dot movie dot genre, and then inside of genre you would list the genre you wanted. And it's just like one line, and that could be really simple. But if you had to do the join of all of the return all the individual people and then filter on them, and then the other thing is that the beauty of Neptune is that response or that query is, it's really easy to just return to the client exactly what you want. There are ways to just return a really ugly blob of all of your data to the client and then work in whatever language you want to reduce that, but then you have a bunch of data on the client side. So it's really interesting because you have the SQL and NoSQL, which in many ways is optimized around the storage and retrieval of information. And now Neptune, while it also takes both of those and graph databases takes that into account, you're really now in this really introspective world where developer experience of performing higher order analytics higher order analytics on your data is now moved not away from other custom code that you may write, and actually pairing more closely to your data so that it can be more performant. And
this it feels to me like the graph databases are sort of a new frontier, and people haven't even discovered all the cool things they can do with them. So it's really exciting to me because we haven't figured them out yet. So I know there'll be some emerging interesting uses that we haven't even thought of yet.
I named an example there, and we walked through it, but I think really, really quickly, some great callouts for examples in games would be something along the lines of like, is there fraud in a given sort of system? I mean, in a video game, you typically have that managed at the transaction level, but like for like banks or like governments, for example, they may use this to be able to look at all of the transactions and figure out, like 4 people who had purchased at this bank, but then had these types of behaviors. Like those are easy to ascertain and then automate, right? So I described a system which may be very manual, where we're trying to just look at the data, but you can actually design pipelines that perform these complex aggregations and combines on graph data sets.
And similarly, you could have, use that exact same logic, which is that I have 4 players who all went to this particular level after they did this level, and you could get those kind of relationships and maybe give gameplay suggestions.
Yeah, and sorry, one last.
Sorry, go back.
No, I'm the worst. I keep coming out with new stuff on the fly. So the other thing is that when you're thinking about adding a new item into a graph database, when you have it in this visual sort of format, it becomes really logical, right?
Yeah.
So if I want to add another person here onto this graph, they just become another node, so another circle. And they are related to these other properties with edges, if it is true. So like you have here on the left, like an artist may have a name, a birth year, and a death year. But if they're also, like connected to a given other edge or another node, like a movie, that means that they like were either a producer or they played a role in that movie or something. If I have another person, I can simply drop in another node, and within that person, they'll have a few properties like their name and their like the ID in the system and their gender, birthday, and then I can very easily just attach nodes, or I can write the edges to attach them to the other nodes. And from a graphical perspective, this is very straightforward.
Right.
And it just sort of drops right in. There's lots of tools to visualize graph data as well on top of this.
That are built on those different platforms you're talking about.
Yeah, built on those optimized, open, standard querying formats.
That's great.
Yeah.
All right, so quickly, we got a couple other things we want to talk about. Document database. Document database is typically for larger data. So in all honesty, DocumentDB that we have here, Amazon DocumentDB is...
I actually am wearing a DocumentDB.
Oh, DocumentDB t-shirt.
There we go.
It has a lot of similarities to Dynamo. The biggest, there's two big differences. The biggest one is that the amount of data you can have per record is I can't remember, it's
in Dynamo?
maybe 20 or 30 times bigger than Dynamo.
Oh, it actually is larger than that.
Is it even larger than that?
Yeah,
okay.
so I
can't remember the exact size.
Yeah, I think I have the numbers. So taking one step back, when we talk about size of data, that's something like that's really important to clarify.
Yeah.
So like we're not talking about the overall size of all of the data in a collection or in a table.
Per record.
In Dynamo, it'll be in a table. It's called a table. In DocumentDB, it's called a collection. What we're talking about there is that again, these are NoSQL. These are blobs of keys and values, structured data. And so for a given value, like if I had, attack, what we mean by the size of the data would be that the value for attack could not be above, I believe it's 200 kilobytes or 100 kilobytes in Dynamo, which, storing the number 1,000 or storing the number 500 is clearly within that bound, right? Typically what we see here is, like people storing massive amounts, like think about storing an extremely large amount of data all as one single value. So Dynamo, not designed to handle that. DocumentDB, again, designed to be able to handle what we call documents, which seems like an arbitrary distinction between, objects, like in Dynamo with key value, but the size is a very big one. The other one will be with respect to performance around having the ability to more arbitrarily define the size and nestedness of your objects.
Right. And the one kind of trade-off for this is that this is not, there's no serverless version of this, is it?
Yes.
You do have to do some server management, so that's one good thing to note.
Yeah, so one really calling out a use case here. So your data blobs can be large. This is really what that in practice is very popular in will be something like a CMS.
Yeah, that's why I
content
said
management
tools,
system.
exactly.
Yeah, so where it's like I may have a website where I may have a lot of content on that website. I may have posts. I may have video pages that have videos and various other things. I may have a song. In Dynamo, the value limit is 200 kilobytes. In DocumentDB, I think it's on the order of megabytes. It may be 10 or 11, 15 megabytes.
Something like that.
So you can actually start fitting entire images actually in binary, like in byte stream form directly into your database, which is very, very different because now instead of having to have a URL to a reference somewhere else, like in Dynamo, like this is the location of my image on S3, here's the URL, and then your application has to parse that to go call it from S3. You can actually store an entire image in in DocumentDB, for example. Or again, just longer form content, and that flexibility of having various different types of documents is valuable. In the game world, a really common example here is, let's say you have a game and you want a single collection that has all of your match data history. But you may have very different game modes, which have very different structures for how you store that data. Maybe you have a free-for-all, a 2 versus 2 versus 2, a 5v5. And they may be entirely different mechanics in each of those games. One may be capture the flag, one may be team deathmatch. You could make a different collection for every single one of those. But the power of DocumentDB is you can have one collection that manages all of that. So that flexibility is really, really key, and that flexibility comes in the form of the design pattern for how your data is structured that you're putting into it, but as well as the size of the data.
Yeah, great. Next one we're going to talk about is ledger database. This is based on, you probably have heard of blockchains. It's been all the rage.
Blockchain, yeah. We got to it. Someone asked in chat, but they're like, did I see blockchain on there?
You did see blockchain.
Yeah.
This is another one where it's a pretty new type of database, and we're still kind of exploring what you can do with it. This kind of brings transactions to the next level, and that's how you can think about it, is that the one difference with a ledger database is that every transaction that's made with the database is cryptographically stored in a way that you cannot alter history. So this is really important when you actually have things that have actual, value beyond just the game. So for example, I want to be able to trade items from game to game. I want to be able to, accept money. You have to have, there has to be no way to basically screw that up. And so that's kind of what ledger databases do. So I've given some examples here. Currency or item trading, auction house, currency, characters or items that can move from game to game. These are all things where you'd want to be able to have a real consistent history of this item and this transaction. That's the purpose of a ledger database.
Something that really comes to mind as a breakthrough use case for something like ledger database would be like if there is some sort of digital equivalent of like real estate. I think of the games maybe like EVE Online. I haven't played extensively, but I know that there's entire fleets. Like people spend a vast amount of time. Like if I don't know. I don't think you can purchase parts of the solar system, but these things become they retain a lot of real world value, and so that data integrity, folks want to feel very secure that is not corruptible to the nth degree. Right, and to ensure that there is maybe another example would be like if there is something where the way you treated an item, like a car would be a nice example, impacts something for the next user and the user after that, you may want to be able to confirm all of the trades that had happened prior to that. Another scenario would be like, well, I don't want to condone loot ninjaing, right? So let's say, for example, all items in your data set, in your MMO that are like legendary or like the top tier of quality, every single time one of those drops, what if you could see a ledger of all of the people who had owned that in the order that they had owned them?
That's a really good point.
So that could be a way of not condoning or not negotiating with people that acquired that in a dubious way. And I think this just unlocks a lot of really cool use cases in games that, again, QLDB is fairly new. I believe it went general availability under a year ago. And so much like Neptune, I think there's a lot of emerging ways to use it, but I'm really excited to see what developers use it for.
Yeah, for sure. I think last database we're looking at here is the time series. Won't spend a lot of time in this. This is a very, very specialized database. This is where you have anything that you want to key basically events to time. And so this was actually, they were originally brought up for storing effectively data for controlling robots and sensors. There are some possible uses in a game. The ones that I kind of thought at the top of my head were detecting player churn and player patterns, looking at what's happening over time with players. Also tracking, you could do like heat maps, tracking location of players over time would be an example. Yeah,
I think what really comes to mind here is like you talk to the IoT origins where you have a phenomena that happens and the sensor wants to be able to read that data and then forward it along somewhere that can store it and query it efficiently.
Yeah.
In the game scenario, typically the game developer or the game engine actually has access to the underlying properties, so there's no need to sample and store somewhere because game developers typically already have access to this information. Now the
Right.
question becomes, where do they store it?
Right.
Game servers may be writing out to game logs directly on their game server instance that are then flushed or backed up into another type of database. TimeStream would make for a great place to be able to store that data because there's a lot of special tuning that has been done under the hood for using a time date as your primary key to be able to sort and access that data.
So especially for logs, I didn't actually list it here, but looking for anomalies is one of the things you can do with that, where you've got a lot of data coming at the same time. Is there something different about it at this point in time?
Yeah, and that's actually one of the biggest, similar to Neptune, right? Like getting introspection about your data.
Right.
Some of the newest databases that we've seen launching from AWS are enabling you to move your analytics and your data processing even closer to where the database is so that it can be optimized as far upstream as possible. And with TimeStream features like anomaly detection, and figuring out what the outliers are essentially, which is similar to anomaly detection. These are things that are going to be valuable, and other sort of basic parameters you would want to find on what is recurring time series data. It's all getting moved closer, and it'll be visualizable in the AWS console, and make it easier to visualize in whatever your external tool may be, either Amazon QuickSight, dashboarding tool you could use, or what have you.
Cool. So we're getting close to the end here.
Yeah.
So how do I choose? This is a big question. And we've kind of talked about this a lot in terms of there are some very general solutions, there's some very specific solutions. It's about trade-offs. Every database has its strengths and weaknesses. You really have to kind of analyze your problem. And once you've analyzed that problem, figure out what database is the best fit for it.
Yeah, and I always like giving this intro to database sort of walkthrough in a very particular way, and that's that if you look back at the history of how databases have been created, there's always been an evolution where new ones are released to solve a need that has arisen or hasn't been perfectly addressed by a previous one. And that's not to say that any new database is better than the previous one, but rather, like I said, we've seen the use cases get more and more specific. So we started with SQL, and if you have a well-designed schema where your data is dense, you will likely not get better performance from any of the other databases. And so even though SQL may be one of the oldest technologies, it has been optimized and improved over time and will work. And so all of these newer ones, are going to fit other use cases. I said before that you will not necessarily be in best practices at scale a one database company or even a one database per data set company. You may have your data stored in one location for one type of use case, and then let's say for your BI or analytics team, you may move it off to Neptune so that they can perform more introspective queries on it. And this is where be open-minded, and in the same way that these databases have been released to solve specific use cases, this is not accidental, right?
Yeah.
We like to say that our databases are purpose-built to solve certain problems, and that happens to be that the new ones released are solving problems that weren't solved previously, and these again come down to trade-offs. It's not about one just not being good enough. It's that in the way that each of these are designed, from how it stores data to how how it's retrieved on the engine level, but then also from the developer experience level.
Yeah, that's true
like
too,
Neptune, being able to actually write queries that are human readable and aren't spaghetti are very important, because that's a blocker to being able to achieve business value from your data. So AWS will continue to innovate in this space. We'll continue to launch new managed databases, but we can't do that without your help. So please, 95% of our feature and product roadmap is driven by customers. So if you are running into a really weird sort of scenario where you feel like your database is not performant and like your data just doesn't have a great option to be able to put it into, we'd love to hear that.
Yeah, and especially games being real-time nature they are, do sometimes have problems and opportunities that we don't see.
Yeah.
Until they emerge.
Once a product GAs and launches, right? It's that's not the end.
Yeah.
Continuously updating, continuously releasing new features, like the RDS data API we talked about before was launched just a few months ago. So continuously innovating, lots of new exciting stuff.
Awesome. This is just a brief slide. I talked earlier, somebody had asked the question about how do we make those HTTPS calls. Here's an example where perhaps you make your UE4, the game is client only, there's no multiplayer. You still want to have a backend where you can kind of store these player profiles and get your friend database and whatever. This is just a real simple example of how you do that. Basically, you have your game clients on the one end. They are communicating with the Elastic Load Balancer to give you an endpoint, which is basically gives you an HTTP address for your calls. You then put those into a Lambda. Lambdas are basically like little functions that run on AWS and
that you don't need to worry
about setting up like an EC2 instance or something like that. They just run, and then that would call your database with the appropriate queries. So it could that Lambda would do all the sanitizing and
munging of the
data,
massaging,
and all that.
whatever.
Yeah, and it would be able to return back and forth the data. So this is a real simple example of how you do that. We actually have, if you signed up for the webinar, there is an ebook that you'll be getting access to, and in the ebook we actually have 2 levels of this kind of server architecture. So definitely take a look at those in more detail. We won't go into it much here because one is we're going to bore everybody.
Last thing I want to touch on, and I guess maybe I think I mentioned it before, but with respect to serverless, in addition to not having to manage the auto-scaling, you're only paying for what you use.
Right.
Which means that you can set up your cloud function with Lambda. You can set up, you can throw some data into Dynamo, and you can set up your Elastic Load Balancer with an endpoint. You are not being charged for your load balancer outside of the request that you're serving to it. So it's on a per request or per 1,000 request rate base. Same with Lambda, you are charged per invocations. So the beauty of all of this is that you don't have to all set it up and then let it run and hope that you're going to get users to satisfy or justify the cost. You're typically only going to get paid then on Dynamo, or you're only going to pay for the data you have stored. So you can set it up, and the cost is going to scale directly with utilization.
Right.
And because each of these services is typically it's supposed to be ephemeral, like Lambda, it spins up, it does its job, it spins itself down, and it should do the same thing every single time for each of the events. You don't have to worry about scaling that infrastructure, and you're only paying for what you're paying for value. You're not paying for having a server that's running.
Right.
And I think that's something that's very important, especially for indie game developers.
Yes.
You want to launch your game and you don't want to have to worry about it just footing a monthly bill and then fighting to meet the cost, right? Like your costs will scale with your utilization, but conversely, the value that you're being delivered because you're having players play your game is also scaling.
Yep.
So as long as all your unit economics work on that end, which Lambda, you get 1 million free invocations a month too, which is. I'm not going to get into all the free tier stuff, but
that's a good point, though. I mean, that's a concern for most of your development process, especially if you're in an indie game. A lot of what we talked about today actually falls on that free tier. So you can get more details on that on the specific service pages. But I think it's good to note is that you can actually get started with this often for free.
I saw out of the corner of my eye, Blue Tiger Animations asked just as I said the free tier, asking if there's a free tier during development. So just like Chris just said, under each individual service page, there will be a different denomination for what is qualified for the monthly service tier there. With Lambda, off the top of my head, I know it's 1 million invocations per month. With each of the given databases, you'll have to look on each of those pages to see what that may or may not be.
Yeah. Great.
Yeah. Great.
All right, so this last slide is just it's a recap of what we talked about, just goes over, lists out these databases again, talks about some of the use cases. Pretty much have covered all this already, so I think, unless you have anything else you want to say.
No, I mean, no outstanding questions in chat. But yeah, I just wanted to say thank you to everyone who came out for today's webinar. Again, intro to databases, 100 level, but I think it's really important to lay the foundation as broadly as possible in the beginning because I know we plan to do some more content similar to this and dive deeper. It's always nice to again have either recurring viewers who we know we know what they may know from having taught in today's video, also, we're just happy to have your interaction in Twitch chat, right? This is a live show. We're happy to answer your questions, and we want you to be along for the ride, right? We're not sort of just blasting this out into the ether. We want you to be along with us, and there were lots of awesome questions from today's stream, so just wanted to say thank you for being an awesome crowd.
Definitely, and boy, we had a lot to say, so it was a lot to cover today. Hopefully it made sense. I've put on here, actually, you're welcome to reach out to us. I've got our email addresses on here. Nick is super active on Twitter, can ask questions there. You can also go to Reddit or r/AWS. I haunt that a lot, and I'm always looking for game developer questions. So please go there and check it out, ask questions. There's a lot of experts there who can answer questions along with me. So would love to hear from you all. And I think we have another poll that's been put on the final poll we have put up there. Also, if you are coming into this stream sort of organically, make sure that you sign up at the bottom. You'll see it in the panel underneath the stream. We have a link there to get this ebook link, which is pretty cool. It's got a lot of good information about getting you started. It's got real good, walks you through how to actually set up everything in terms of getting a database running, getting a backend service. So I encourage you to go sign up for that. You can see that linked in the panels underneath the stream. And like Nick said, I think you have to minimize your window to see that. Is that right?
Yeah, I'm going to throw that link. I just threw the link in the chat.
Oh, there you go.
So
okay, thanks, Nick.
Again, if you haven't signed up, signing up here helps. You'll get that ebook. Additionally, if you follow our Twitch channel at twitch.tv/AmazonGameTech, you'll be able to be notified going forward, or you'll see us on your little users bar when we go live again in the future. I tweet out whenever we're going to be going live, typically about a day in advance, and then again right before we go live. So follow along wherever applicable. If you have any game tech questions, we're both super available. But with that, I think we're going to close out for today, right?
Yeah, great. Thanks,
All right,
Nick.
Awesome. Chris,
Good.
It's been great.
Good talk. Thanks, everybody.
Thank you, everyone. We will see you on the next episode, which will be announced at some point. So stay on your toes and be on the lookout. We'll see you soon.
Bye.
Thanks again.